Hey guys, this is Miss Smith. We're going to be doing perimeter and circumference. Okay, some vocabulary to know before we begin. Okay, so let me get my pen. Okay, so perimeter is the distance around any polygon. Okay, let's review what polygon means. Polygon is a closed figure with straight lines. So polygon would be quadrilaterals, triangles, hexagons, all those sorts of things. What's not a polygon is a circle is not a polygon, okay, because it doesn't have straight edges. So we're doing perimeter of polygons today. Okay, now another thing we're doing is circumference. Okay, so you ask, well, how do we find the distance around polygons? We do it with perimeter. Distance around a circle is called circumference. So it's the distance around a circle. And you can kind of put those together because they both start with a C. Okay? So perimeter is called, and obviously these start with a P. So perimeter of a polygon is we find the distance around a closed figure with straight lines. Circumference is used as talking about the perimeter of a circle. Okay? Now, to find perimeter, just add all the sides. That's all you got to do. Add all the sides. So when we're talking about straight line polygons, then it's easy. You just add all the sides. Now, circles a different story, and we'll get there after we get finished with this. Okay, your formula chart gives you a formula for rectangles only. Okay, so we are going to be adding the formula S plus S plus S dot dot dot. So if I have a hexagon, how many sides am I going to add together? Very good, 6. We'd S plus S plus S plus S plus S plus S. Okay, 1, 2, 3, 4, 5, 6. Okay, so we just add all the sides together. So on your formula chart, I want you marking out whatever formula it says for rectangles only, because we need to use it for everything, not just rectangles. So we're going to rewrite S plus S plus S. Okay, to show that no matter how many sides a figure has, you just add them all together to find the perimeter. Okay, which we're talking about polygons. That's something you will need to add to your formula chart as soon as the star begins, and we'll talk about that in class. All right, find the perimeter of the following polygons using FSA. Since perimeter is just a straight distance, the labels will be regular units. Okay? All right, now, FSA. When we do FSA, the F means formula. The S means substitute, okay, which means I need to replace my variables with actual numbers. And A means answer. You will be doing this, for the next probably 3 weeks. So we need to get in the habit of doing F, S, A. That's how we show our work. And you did in 6th grade, so I'm sure some of you are familiar with that. Okay, formula. What's our formula on our formula chart that we just made for the perimeter of polygons? Okay, S plus S plus S. Very good. We have 3 sides, so we have 3 S's. So to substitute my variables in, I got to figure out what my sides are. Okay, I have a 6 by 8 by 10 side. So all I do is plug in for my variables or substitute. So it'd be 6 plus 8 plus 10. Okay, perimeter means around a polygon, around a figure. That is what perimeter means. So my area would be 24 meters. Okay, pretty easy. All right, let's go to find the perimeter of a trapezoid, right? Hope you knew what this shape was by what we did earlier or a few weeks ago. Okay, so the perimeter of a trapezoid is we need everything around. When we're talking about perimeter, it's around a shape. So sometimes they give you extra information. What do you think the extra information is here? Okay, I hope you figured it out. I don't need this for. I need this for when I do area, and we're going to talk about that in a few days. I don't need this for because all I need is the numbers around my figure. Another thing we need to figure out, if this side has 1 tick mark, then what do you think this side's length is? Very good. The same thing as the side with the 1 tick mark. So this would be 5 centimeters. Okay? So now let's do our side, or our formula. Our formula is S plus S plus S plus S, because I have 4 sides this time. 1, 2, 3, 4. So this would be 7 plus 5 plus 5 plus 12. Okay? Now, when I add all these up, it would be 29 centimeters. Okay, why didn't we add the 4? We just talked about it. It is the height of the trapezoid, not a side. Okay, so S means side. So it's not a side, so we don't add it in there. How do we know to add the 5 twice? Tick marks. Tick marks show equal values or equal measures. Okay, oops, I spelled marks wrong. All right, moving on. Name the shape and then find the perimeter. All right, let's name this shape. Well, we need to figure out how many sides there are. Okay, we have 1, 2, 3, 4, 5, 6. Okay, so what kind of shape is this? It is a hexagon because it has 6 sides. All right, now, is there a faster, okay, hold on, let's start with FSA. So our formula for perimeter of any polygon is just S plus S plus S. Okay, how many S's do I need to do this time? It's a hexagon, so we have a 6-sided figure. So it's going to be plus S 6 times. 1, 2, 3, 4, 5, 6. Okay, so what do I plug in for S? Okay, we're going to substitute or plug in. Well, since I have 1 tick mark on each of my sides, that means each side is going to be 1 5/10. Okay? Now I'm putting parentheses around it because I'm going to show you a faster way than adding 1 5/10 6 times, which if you would like to do that, you are more than welcome. But is there a faster way since all the sides are equal? Okay, that's our question. Yes. Okay? Why can't we just multiply? Multiply by what? Oops, oh my goodness, sorry. Multiply by what? What do you think? If we have 6 sides and we know each side is 1 5/10, what are we going to multiply by? Very good, I knew you knew. Okay, 1.5 times 6. Okay, and then of course I hope you know how to multiply decimals by now. Okay, this is how I would set it up and move it over once. So when we multiply, we get 9. Okay, because of course you move it over once because there's one spot to the right here. Okay, so my answer would be 9 meters. Okay, if you want to add 1.56 times, you're more than welcome, but a faster way is knowing how many sides you have and multiplying it by the length of that side. Okay, here we go. You must know these 2 vocabulary words in order to find circumference. Okay, we're still doing perimeter. Perimeter is called something different. When we are working with circles. Okay, so perimeter is called circumference when we have circles because circles are not polygons. Okay, so here we go. Blank is a line from the center of the circle to the outside. This is called a radius. You learned this last year. So let's repeat this. Radius is a line from the center of the circle to the outside. So a radius, you'll see in the next slide, is, okay, this isn't accurate because I'm drawing it, but a radius is half from the center to the outside. What do you think takes up the full thing? Y'all remember from last year? What do we call this? I knew you knew again. Diameter. Okay? Diameter. This is the length from one side of the circle through the center to the other side. Alright. One way to remember it is radius is a shorter word and it's a shorter line. So radius is a shorter word and a shorter line. Diameter is a longer word and it's a longer line. It goes from the center to the end. So here, what do we think this is? Okay, here's our center. It goes from one end of the circle to the other, and what do we call this? Very good, diameter. Alright, it goes from the center and only takes up half of the diameter. That's called radius. Now, our variables, when we look at this on our formula chart, diameter, of course, stands for d, and radius stands for lowercase r. So on your formula chart, I want you to find circumference, which also means perimeter. It means the distance around a circle. So we're talking about the distance around a circle. This is what diameter means, okay? Now, it gives you two formulas. It gives you pi d, and it gives you 2 times pi times r. I always tell my kiddos that this formula right here gets confusing with the area of a circle. So I want you to mark that out on your formula chart. I want you to mark that out. Let's just use pi times d. Now, one big thing I want you to know right here is that we are going to use, well, let's go to the next slide because I think it's on here. Yes. To find circumference of each of these circles, of course we still use formula, substitute, and answer. This is how we show our work. We are going to use pi equals 3. Okay? Easy, easy, easy. Because what does it say on your formula chart? It says pi equals 0.14. Do I necessarily like to multiply by decimals? No. It's just so much easier if we can round to 3 and get our answers close enough to our multiple choice answers that we can take a good guess here. Okay? So formula for a circle, for the circumference of a circle, is circumference equals pi, which means 3, times diameter. So what would I plug in here? Well, I know pi, told you up here that you can use 3, so I know it would be pi times, what's my diameter here? It gives us the diameter, so it's pi times 9. My diameter here is 9. Before you start, though, I must tell you that I do tell my pre-APs to do this. I want you to find the radius first and the diameter, because when we start doing area and circumference together, it gets confusing. So you always want to know what your variables are before you start. So if the diameter is 9, what is half of 9 to be our radius? Very good. I knew you knew. 4.5 or 4 5/10, okay? So coming back here, what is 3 times 9? 27. Very good. So circumference equals 27 inches, which means the distance around the circle. Okay? All right, now let's do this circle now. All right, so what is my formula for circumference, which means the distance around a circle? What would my formula be? Well, same thing that we just did. So it's going to be 3 times my diameter. So we're going to substitute for our variables. So 3 times, what do we need to do? My radius is 14, but what is my diameter? My diameter would be double the radius. So 14 plus 14 would be 28. So 3 times 28 would equal, if we did it on the side, we would get 84 meters. Okay. So why did I use 28 instead of 14? Because this time we had to double the radius to find diameter. Because radius is half the diameter, and doubling the radius gives you the diameter. So we need to know what each of those are before we start, especially when we start mixing area and circumference. Okay, here's one question that I didn't teach very well last year. I didn't bring it up that much, but I've seen it on a lot of questions from last year's STAR. So I really want to make sure we know this. Okay, so notice that we're still talking about circumference because we're talking about circles, and I see 2 circles here. All right? So what do these do when you ride your bike? They rotate, right? So they rotate, and we're gonna see how we're gonna answer some questions about rotations. Notice how this, I kind of show you a picture of how you're gonna rotate, and clearly if you've ridden a bike, you know. Okay? The circumference of a circle is the total distance around the circle, correct? Hopefully we've got that by now. So circumference it's a long word. Circumference equals the diameter. Circumference equals the diameter of the circle times 3, which is about 3.14. And we just talked about that in the last slide. So 1 revolution of a wheel will make it move a distance equal to its circumference. All right, so if this is really confusing, I'm going to read it one more time and then we're going to do an example. The following problem is the kind you might see about a wheel revolution or rotation. So revolution means the same thing as rotation, okay? So let me read this again. The circumference of a circle is the total distance around the outside. Circumference equals the diameter of the circle times 3, which is about 3.14. 1 revolution, or 1 time around that your bike would move, will be equal to its circumference. Okay, so let's do this example. Okay, Billy likes to go bicycling. His wheel has a diameter of 16 inches. So I'm going to draw a picture, and I know that his wheel diameter is from all the way from side to side, so the diameter is 16. How far will he go if his wheels make 20 complete revolutions or rotations? Draw a picture of the wheel. Okay, so if I know that the outside of my wheel is called the circumference, right? So 1 time around, I'm going to show you this in class on a video, because your wheel, if you have what I want you to do if your parents will let you, if you have a quarter, if you paint the outside of a quarter and move it, and I'm going to show you this in class, and move it, then it becomes a straight line. It's like taking this line apart and it becomes a straight line. So if this was a yarn, I would take it and make it a line, then that's what circumference is. But then you put it together, it becomes a circle. And I'll show you all a video when we're in class. So how you do this is I need to find circumference. So circumference equals pi times d. So we're going to round and say this is 3, of course. So pi equals 3. And my diameter, it told me, was 16. So 16 times 3. 16 times 3 would be, okay, so we have 18, carry the 1, this would be 3, so 48. All right? So 1 revolution would equal 48. 1 revolution would equal 48. So what if I needed 20 revolutions? Well, all you do in the end is one more step. If it goes around 20 times, then I need to see what 48 times 20 is. Okay? So 48 times 20, I'm going to do this with you, 0, 0, and then do your placeholder. 2 times 8 is 16. Carry the 1. This would be 8, 9. So your answer would be 960. 960 would be your answer, because at the end you just multiply by 20 because you're going 20 times around. And like I said, I'm showing you this now so you just get a little introduction, and I'll show you a video in class since I can't do it on this PowerPoint. Alright, you guys, make sure you fill out the class survey and do the problems, and this is part of your grade, so y'all got to be careful and make sure you do this, otherwise you know the consequences. Make sure you hit submit. Alright, y'all have a great night. See you tomorrow.